Today we will be discussing piston bowl geometry and internal conditions. My name is Caleb Marlatt. So for my initial research, I wanted to look at 3 unique piston bowl designs and look at the flow patterns with each of those. So a little bit of background: different fuels and different fuel injection methods require greater or less turbulent intensities depending on what the application is. So carburetors would require less turbulent intensity within the cylinder because it has the entire intake manifold to mix in, whereas direct injection needs high turbulence within the cylinder to mix that because it only has the one cycle to mix. So yeah, this even turbulence creates even heat transfer throughout the cylinder head or the piston head, and it creates a better thermal efficiency. So my preliminary designs, I kept them simple but unique to reduce the variables. This meant keeping a constant clearance volume and constant quench area. So my inlet conditions, I wanted to keep one intake valve. If I would have 2, it would just reduce the turbulent intensities, and I just wanted to see the extremes within them. If I had 2, it would just reduce it at the same rate for all of them, and it would create less contrast within the models. I also used a flat valve head for simplicity, just to keep it constant throughout, and then constant pressure and velocity through the intake valve. And this used an air-fuel ratio of 14 air to ethanol. And then I can adjust these to mimic boost pressures later. So my results, as you can see, the stock one created the highest turbulent intensity with the max being around 99. Kind of the double bowl was around 72, and the cone shape was right at 50. So yeah, the stock version would be best for direct injection, whereas the cone would be best for carbureted, just because it's less intense and you don't need that mixing within it. And then I also did an additional study with a Hemi design, and I wanted to look at the effect of fillets within my design for that. And as you can see, this bottom one has the fillets and the top one doesn't. The top one's max is around 80 and the fillet version is at 100. So this created a 20% increase in my turbulent intensity just by putting 2 fillets in the corners. So my next steps would be to carry out additional studies with varying conditions. This would be studies over multiple pressure ranges. This would just give an idea of which pistons would be best for different scenarios. So if you were looking to put a turbo or put boost through your motor, you would need to see how it acts through all those pressure ranges. And then also changing the valve angle. This would affect how it enters in through the cylinder, affecting the turbulent intensity. For this, I kept it constant with that flat valve head. And then the last one being increasing clearance volume. This would just have more volume to mix within the cylinder, and then this would just give me a better understanding of the best bowl configuration for each application. And my references. Any questions?